Okay, welcome back to Wickerson Studios. I'm going to continue with the 13th or 14th video of this series dealing with NumPy Basics, array and vectorized computations into Grasshopper canvas, which will then lead to Rhino 3D geometries. Now, if you've been following the last 13 or dozen videos or so, you'll see exactly where I'm at. It's fairly straightforward. I'm just going to pull up a couple other guides for myself, even though I don't really need them. But we left this second Grasshopper AI Copilot AI Stable Diffusion, and I expect to make this is 002 of the Grasshopper script. Well, I'd gotten into it, and I was making some pretty specific videos about the NumPy basics of array and vectorized computation. And I think we'd gone through and made the zeros array. And then as soon as I got to the ones, it just got fairly repetitive. So I thought, well, what I'll do is I'll just run through those numbers before adding and moving arrays. I think it was up here. So the NumPy, what I'd done is after the zeros array, zeros before zeros like and before ones like, I produced the ones array, which is here. I produced the A range array, which was here. And I'm not going to do these for you in video. I think they're pretty straightforward to download this, see my notes, get the app, and run through the A range. Then see what I did after that as I jumped up here. And I continued with it with the ones like. And then I went down and did the empty like, one zeros like, empty like, probably did full like after that. Yeah, full like. And so those are all pretty straightforward working with arrays. You can see that I'm set on pretty much the 4x4 array or 4 by whatever length of column you want. You do have to set your rows in so you can output the arrays to list by numbering them. That's one thing that kind of stinks a little bit, that you have to number them down here. Sometimes you use a 3x3 array. But when I got onto the iArray, that was pretty interesting. The iArray is a pretty wonderful tool that you can slide through your ones in an array format. And if you saw that running, which I shouldn't be running without running it, you'll see down here, as I'm sliding through that, you can see that so long as I've taken the cache off, you see that I'm moving that array to the -3 position, the -2 position, the -1 position, and then the 0 position right down the middle. You get the identities matrix at 0. It's then brought out into a tree form for Grasshopper. So that's going to be a really amazing tool. Then I have the identity array as well, which is pretty much just setting that to 0. So that's pretty simple just for a 4x4 array. So not a very useful node. If you consider that you got to bring in 4 and output 4, you could pretty much use that through the iArray and give yourself some more functionality or parametric computational functionality. Then I did the data array type casting. So I took a float and I put that into integers value, and you can make tons of arrays that do different things. You can make them all parametric, so they're sliding through different letters, which will then read the code into your script. That was pretty interesting, the casting. So let's get past that. And what really happens is you end up knowing from that you can move integers, unassigned integers, floating points, complex floating points. So I left a lot of notes in here for somebody that wanted to continue and generate a ton more scripts out of here from casting. But it's pretty tedious and similar, so why not do it when you need to do it? And then I got into arithmetic arrays, which really is the beginning of understanding what vectorization is. You can process these very quickly. And the first one was adding arrays. So I really was taking 4 lists in to produce 2 arrays and then produce them from an additive array. And then I kept that going, and it gets a little wiry crazy here, and I should probably make it more simple and bring these down. But I did multiplication, which was element-wise. This is all element-wise array arithmetic behavior. Then I did subtraction, then I did division, and I think I did something interesting. After dividing, I just left this open to where you could go with exponents and square roots. So after the dividing, I put it through exponents, And so here it is. I get that done for you in exponents, but exponents really can work by powers or square roots, but I even put the square root in there as well. So you keep processing through there, but you see they get more and more complex. Next thing you've got logical operators and comparison operators, which I did, but I slid in between that some logarithm, which was fun, logarithm base 10. So that's what's happening here. Powers, square root, logarithm, logarithm base x, and then, of course, after you get into that, you want to do all your trigonometric functions. So I did sine and cosine for you under trigonometric functions, and I left all the tangent functions through to inverse hyperbolic functions up to you to do. But I did throw a little bonus that wasn't coming out of the book just because Copilot picked it out for me and then decided to generate a there's the NumPy cos. There's the ones I didn't do. It gave me a nice rounding factor. So I thought that was nice for decimals. So you could play off. Now, obviously, this isn't doing anything because my source code is, my gene pool is not to like 6 decimals. So if I generate that and then do a quick randomized, that's going to update everything and come down to this randomized. You can see that now I have control over how many decimals I want to throw in an array in a very fast vectorized form. So that was pretty exciting. And then I go into comparison operators. And I was going to continue with this for you because I have them up and running pretty simply as 4 lists that come through and are processed, and then they are compared. And my first comparison function was greater than, but I'm leaving that up to you to continue with less than, and I might generate that for you. And then down below, I've left this open in the script for people that want to do more. Logical functions, the same type of thing. I started with logical and I'll take that through logical and then logical or, and nor, and XOR. So why don't we do a couple just so it's not just, and then what I'm going to do is I'm going to take this into some really cool data visualization for the next video. So I'm going to spend a little time making this one produce some interesting geometries, because the point is not to just bring it in the Grasshopper to do nothing with it, but to generate some of that creative geometry. So what I'm going to do here is comparison operators. I'm just going to grab this. I'm going to copy this down here. I'm going to change this to less, and you can do less equal. Yeah, you can do anything, but I'm just going to do less function. I'm going to eliminate this one. I'm going to stop our scripting. Copilot will take over. See, it wants to do less than or equal to. Let's just start with write a ghops component, and it should behave exactly the same as it did above because you've trained it less than. Let's run through it. It's this fast, and if you can get Hub Copilot going, you can write your own apps themselves. They'll write it for you. I am curious about that holding to list. Wonder why I didn't bring in the lists as I guess it'll default to item. I don't need it as a list, but maybe I need an HS hops param access. But since it's running without it, I think I'll be okay to do it. Well, let's bring that one in. 1, 2, 3, 4, and that'll close off my inputs. And let's get right to the outputs. 1, 2 booleans, and that'll be it. That'll give us both sections, and we can basically see the same. Let's see the same process of processing array 0, 1, and we're checking out if it's less than. So that's it. And it would be interesting to see what it wants to do for us after less than or equal to. I guess you could do that. You could do, what else would it want to do? Greater than or equal to, So you could do all these ones not equal to, and you get into the exclamation mark. But I'm going to leave that for you to do. But while this is running, let's run the program. Let's grab our IP address, and let's do a quick little hops node, because that's really the only component you ever need anymore, which is making Grasshopper more computational and more coded. That's for sure. We'll go up here to the less than call, and we'll put it in here, and we should have no problem with our less than call. Let's check if these numbers are less than 1, 1, 1, 0, 1, 0. Let's see how this data compares with the data above. False, 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 true. And I think it's the same data, 0, 1, 0, 1, same patterns as true, true, false, true, false. This is false, 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 true. So it looks like it's working. I'm just going to hit my left, get my call name, and you get very proficient with this if you start using hops. It's a very powerful tool. I hope it goes, I hope a couple things get solved with the arrays to tree. They probably have done that. I just haven't found it. So that could continue. So what I'm going to do is just grab this here, copy it, and leave this for you guys to do after I've shown you a little demo on that. And anybody who wants to do this, there we go. Those are what is going to happen. And then the same thing we could process down here. Logical operators, maybe with a nice title page. We're going to do a logical XOR and see if this solves the same right to a GH component. And this is going to bring in, we're also going to bring that down to just what it is. We don't need the, I number it because that's an issue when you're developing, and I've said that in many, many videos. You've got to change the name every time you bring it to it because it kind of remembers what's going on. I think you can kind of clear it here with preferences and getting rid of 1,052 cached items. So, and you can also, you want to take off your cache here. So when you're running, you can kind of debug what's happening. And so let's take it through inputs. Let's get our list in. I don't want to untrain my GitHub to be using param access because we need to know if it's a list. I'm not bringing in trees yet. That's going to complicate things well beyond what I want to do. And there's our less than script. And here is our definition. And here is our script. I'm going to trust it works. Oops. Looks pretty good to me. Let's get less than logical OR in there. I think we're pretty good to go. And it was going to do a logical NOT after that. And it probably will do a logical XOR. And that's enough. So I'm going to, and now let's go back into mathematical functions and trig functions. But we don't have to worry about that. Let's just do a quick cut and paste. That's why these scripts are going to be very helpful for you, that I've designed them. You won't have to logically go back through here. Logical and, this was the logical OR. And function, and we can delete this one. We can grab our hops. We can shut off our last one because we have to save. You cannot save while running. And there we go. Another call. Get this thing up and jiving. It's like the world is one big computer. It's kind of terrifying, but it sure is moving quickly. So I'm going to grab that OR copy. I'm going to paste it in here, and we should be able to compare these to the ands, to the ORs, and then you could even put the XORs in. It should be working fine. True, 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 true. The other one was true, true, false, false, which makes sense. And we will double click left, grab the call name. And you will have to do that because when you reset up these nodes won't be working. You'll have to re-put them in. It's a little bit frustrating to do that, but it's good practice to name and also take off your caches so you can debug what you're doing if you have to customize other things. And we'll change this over to OR, a logical OR. That's right. And I think we're good to say that is it. Waiting for a very interesting data visualization. But this is the GH script that I've made for you, the GH002. We can clear this out. We could start with the vectorization as a tool, and we're going to go into the next section after this. Let me see where it is. We're really looking at the vectorization, not just building NumPy arrays, but now using vectorization in it. And that is enough said. So I will stop recording and get ready for a very interesting data visualization geometry using comparative and logical operations and maybe some identity matrices and I matrices. Thanks for watching.